So next move for 1:4 demultiplexer. Select new and give the name as Demux. Next, finish. You need to choose file, add new project. So this is done. Go to project, new source, select verilog module, give the file name as Demux 1:4 demultiplexer. Next, select the value as D acting as input. I have only one data, and to choose select line, the select line is also acting as input. Choose LSB bit and MSB bit. I have a two select line 0 to 1. Then I need to select Y. You have to select REG with Y, and it acts as an output because I have a 4 output line 1:4. Then you have to 0, 1, 2, 3. Then you have to choose 3 and click on next. Click finish. Then I need to write a program here. You need to change REG here instead of the last. See, because here this version will get an error in that one. And after that you need to copy the program for 1:4 demultiplexer. The 1:4 demultiplexer is start from always to the end module. The end modules is already there. Then you will get a duplication of that. So remove that one. And I write a program for always, begin and Y cases. The 4 cases, the default cases, I need to write all the values to be 0. End cases and end module. Save the program. I need to check it by using the check syntax. If there is no error, let me go for the adding for the test cases for the 1:4 demultiplexer. Let me running in the implementation module. So we wait for the some minutes. After that there is no error. Click on this module, right click, new source, select the verilog test future, start with the T and Demux 1:4. Then next, finish. Then another window will be opening. Then all the inputs, outputs and initialization test has to be written. You need to change the demult as the data as 1. So I have a 2 value have to pass. You can write to apostrophe as B and select line has to be 0. After 100 nanosecond you need to change, and you can also copy the program of this for the test benches with the different cases. I need to write the 4 different cases. Then select line is 2B00 100, select line is 01 and select line is 10 and select line is 11 and end module. Then you can remove these two, save the file and go for the implement simulation and click on your icon here. ISE simulator will be selected and click on this simulate behavioral model. If there is no error, so you will generate a waveform, and depending upon the select line, the data has to be moved from one to another. Select this, then you can check it out. If you want the data, you can see slip 5 that. So you have icon has to be moved. My select line is 00. The output has to be getted here 001, the first line. The select line is 01, then data has to be moved for Y1. Select line is 10, the data has to be moved from Y2. The select line has to be 1, then data has to be moved for the last bit. So you can also see the data whenever you have choose select line as 000, the next is select line is 01, the next has to be select line is 10. So we can also check it out here. But somehow depending upon the versions, you not getting a 00, you will get it H0. The H0 is also will be equivalent to the 00. H1 is 01, H2 is 10 and this is 1. And that is, don't worry, the waveforms will be generated. Don't worry about the H, whatever you're getting. So that is also equivalent to this version. So depending upon the version, the data value has to be changed. So here to need to know Y0, Y1, Y2, Y3. So what are the value here? The same thing is also displayed. Says whatever you are running in the lab, it may not happen, but you will definitely you will get the values. So that assumes then you are getting the answer for that one. So don't worry about what is the H value getting for all those things. So if you check it in this value, then your answer has to be correct. And you can also practice for the 1:2 multiplexer as an assignment. Thank you.